All right, hey guys. If you weren't here last time, so what I'm gonna do is probably give another 2 or 3 minutes for anybody else to get in here, and then I'm gonna go through kind of some general reminders. So, like when I flip this back around, the stuff that I had written on that board, I would probably screenshot or write that down, and then we'll go through some of the problems that are in the remediation assignments that I posted. And then if you have any questions or want me to do some more examples or whatever, I will stay around as long as needed for that. Um, I'm not going to do too much from 8-1 because when I sent out that survey about what stuff you guys wanted to retake, nobody said they wanted to retake part one of the Unit 8 assessment. So I think everybody's grades there for the most part were pretty good. So I'm going to do part two and part three. And then when we're done with that, if there is somebody that needs to retake or take part one and you want me to go over some stuff from that, I can do that. All right. So I'm going to give about 2 more minutes for anybody to get in, and then we'll get started.
Miss Speaks,
What's up?
how's your break been?
Um, Not too bad. Doing a lot of walking with my dog.
Nice.
Yes.
Mine's been boring.
I miss sports. I want to watch baseball.
Yeah, me too. I want to watch the Braves lose some games for sure.
Stop. They're going to be amazing this year.
Yeah. Yankees will win it though. So I still can't believe the Nats won it. That was annoying.
Yeah.
Oh yeah, they're in your division, so that sucks.
I know. Okay. So biggest thing for Unit 8 is factoring. If you can't factor, you're not going to be able to pass this test. Okay. So I have some reminders up here again. If you joined after I said this, then you're probably going to want to screenshot this or write it down because I'm about to erase it in about 30 seconds. But we'll go through some examples of each of these kinds of things. But remember, when you're factoring, the first thing you're always going to look for is a GCF. It will make your life a million times easier. Some of them you can't factor them if you don't do the GCF first. Okay, so always look for that first. And then after that, it's dependent on how many terms there are. So if there's only 2 terms, it could be either a sum or difference of squares, well, difference of squares, or a sum or difference of cubes. And I'm going to go over an example of each of these. Okay. If it has 3 terms, that's where we were factoring using the x. If a equals 1, meaning there's no number in front of the x squared, those are the easy ones. That's where you just fill in the x, and those are the factors. If a does not equal 1, meaning there's a number in front of the x squared, so like 4x squared plus 7x plus 12 or whatever, that's where we have to multiply a times c and then factor by grouping. And so I'll go over an example. If there's 4 terms, we're just going to do it straight by grouping. You also have the option, if there's 3 terms, of using the quadratic formula. Okay, so you're going to want to know that. I'll have to double check on the form. I'm not sure if we put the quadratic formula in there or not. If it's not there, I'll add it though, because that's not something that we have asked you to memorize. Okay, so I'm going to erase this stuff. All right, and so I'm looking at the Unit 8 remediation for part 2. So I'm going to just pull some examples from there. All right. So number 34 there, x cubed plus 27 equals 0, and they ask you to solve that. Okay, so again, go through your steps. First thing is GCF. There's no GCF between x cubed and 27. All right, so then it only has 2 terms, and this is cubed. So I'm looking at it being a sum of cubes. All right, so x cubed, I can take the cube root of that. Can I take the cube root of 27? All right, yes, 27 is also a perfect cube. So this is where we did SOAP. All right, and this is something that is not going to be given to you. All right, that's something that you need to know. You need to know how to factor this using SOAP. So remember, this stood for same, opposite, always positive. Okay, so I'm going to take the cube root of each term. Okay, so the cube root of x cubed is just x. The cube root of 27 is 3. That is A and B. And then in your notes somewhere, you have it written out where it's like A plus B times A squared plus or minus AB plus B squared. Okay, that is what you need to know. You should have this somewhere in your notes. Okay, this is how we factor sum and difference of cubes. So x is A, 3 is B. Okay, the first one, okay, is always the same sign. So in the original problem, it was a plus. So I'm going to do A plus B. So x plus 3. All right, then it's A squared. So x squared. All right, the second one is always the opposite sign. So this one was plus, this is going to be minus. A times B, x times 3 is 3x. The last one is always plus, B squared, 3 squared is 9. All right, and then if you were just factoring, that would be your final answer, but Unit 8 is not just factoring, it's factoring to solve. Okay, so this x plus 3 is a factor that I can set equal to 0, and I can solve it. So I would get x equals -3. That's one of my solutions. All right, this second part in here, it's factored as far as it can go, but to solve it, we're going to need to use the quadratic formula. All right, so again, A is going to be this coefficient. So 1 is A, -3 is B, +9 is C. Okay, so quadratic formula, x equals -b. Well, -3 is +3, plus or minus the square root of b squared. Very, very important that you put this in parentheses, especially when you put it in your calculator. All right, b squared minus 4 times a times c all over 2 times a. All right, I would put this whole thing in your calculator all at once. Okay, so without the square root, put in parentheses -3 squared minus 4 times 1 times 9. And I am going to run downstairs and grab my calculator real quick. All right, so while we're doing this, guys, I can't keep in mind I can't see you, because I'm standing out like in front of my tablet that I'm using. So this is like weird for me because I feel like I'm just talking to the air. So while we're doing this, if you have a question, turn your mic on, all right, and just like you would in class, stop me and go, wait, where did that come from? Okay, so in here, doing that math, all right, I got negative 27, and then 2 times 1 is 2, okay? And so then what you're going to have to do is simplify the square root of negative 27. All right, and that's where we did our trees. You guys remember these? The 27 is 9 times 3. 9 is 3 times 3, so I have a pair of 3s that goes outside, and then a 3 left over that is inside. Because it is negative, I'm going to put an I. So 3I square root 3 over 2. That is my other two solutions. All right, 3 plus 3i, 3 minus 3i, but you don't have to write them out separately. You could just leave it as plus or minus there. Okay. Are we good there? So far, so good? Okay. Again, I'm just going to skip around a little bit. So let's look at number 40. Okay, so again, we're factoring in order to solve. Okay, first thing I'm looking for is a GCF. So all of them have a t, so I can factor out a t. That will leave you a t squared minus 3t minus 10. Okay, and now we're going to look and see if we can factor this piece. So I'm looking for two numbers that multiply to negative 10 and add to negative 3. All right, I could do, so multiply to negative 10, add to negative 3, negative 5, and positive 2. So those are my two factors, t minus 5 and t plus 2. And then when I want the solutions, I'm going to take each of these and set them equal to 0. A lot of times we forget this piece. The one that we factored out, it still counts. So I have a solution of t equals 0. I have t minus 5 equals 0. I have t plus 2 equals 0. So t equals 0 is a solution. T equals 5 is a solution. And t equals negative 2. Gives me 3 separate solutions there. So far, so good? Let me see if I can find one that you have to do by grouping. I'm just going to make one up, okay? So 2x squared plus x minus 3. Okay, so if we were going to factor this one to solve it, all right, there's no GCF. We have 3 terms, so I know I'm going to be using my x. Okay, but there is a number in front of the x squared. So when that happens, that's where we have to multiply. So I get 2 times negative 3. So I'm looking for numbers that multiply to negative 6 and add to positive 1. Okay, so that's going to be positive 3 and negative 2. What I'm going to do with these two numbers is I'm going to split the x in the middle apart into positive 3x and minus 2x. Okay, so I now have 2x squared plus 3x minus 2x minus 3. All right, I split the middle term apart. Now I have 4 terms, so I am going to factor by grouping. All right, in my first group, the GCF is x, and that leaves me with 2x plus 3. In the second group, remember we have to make this match that one. So the GCF that I'm going to take out there is a negative 1, and that leaves me with 2x plus 3. Okay, so my final answer then, well, not my final factors are going to be what's inside, okay, 2x plus 3, and then what's outside, x minus 1. Okay, now it's factored, and then to solve it, it's just setting those factors equal to 0. 2x equals negative 3, x equals negative 3 halves, and then x minus 1 equals 0, and x equals 1. Okay, so those are all of the different kinds of factoring, all right, that you're going to need to do. All right, SOAP, sum and difference of cubes. All right, factoring the ones where we have to multiply, factoring like we did the last one, the easy ones, where you just use the x, and then factor by grouping is this piece right here. Okay. The other thing that's super important in 8.2 is being able to write the function when you're given the zeros. So like I'm all the way back up at the top of this remediation assignment. And it says x equals negative 2, 1, 2, 2, and it asks you to write the function. All right. Remember that these are zeros and factors are opposites. So if I have a 0 at negative 2, I have a factor at x plus 2. Okay, same thing. If I have a 0 at positive 1, I have a factor of x minus 1. Okay, and then the two 2's you can write it one of 2 ways. You could write out x minus 2, or you could write it as x minus 2 squared. Either one of those would be considered correct. This is factored form. Okay, so you have to read what the directions are asking you for. If they want it in factored form, this is it. If they want it in standard form, that's where you would have to go through and multiply all of these things out. So you would have to FOIL these two. This, remember, x minus 2 squared is x minus 2 times x minus 2. So you would have to FOIL those two, FOIL these two, get your answers, and then FOIL again. Do you need me to go through that as an example, or are we okay with the FOIL part? If you would like me to FOIL this out so you can see it, let me know. Okay, everybody's good with FOIL? I figured. Last thing that I want to talk about in 8.2 is multiplicity. Okay, so the other thing that you might be asked to do is, like, if I give you this, all right, so now we're going to work backwards. Instead of going from here, I'm going to give you this piece. And I'm going to say, what are the zeros and what are their multiplicities? Okay, so remember the zeros, we're going to go backwards. All right, so you would set this equal to 0 and solve. So this would be a 0 at -2. This would be a 0 at +1. This would be a 0 at +2. And then the multiplicity, all right, we're looking at the degree. So neither of these have an exponent, so they have a multiplicity of 1. This one has an exponent of 2, so it has a multiplicity of 2. Okay, and then remember what that looks like on the graph. So if I were going to graph this, I know I have a 0 at -2. I know I have one at 1, and I know I have one at +2. And it doesn't really matter like what happens over here. Just know that this, when it has a multiplicity of 2, that's where it touches and turns around. Okay, so this graph might look something like that because I know when it hits +2, it's going to touch the x-axis and turn around. That's what it means to have a multiplicity of 2. Okay, so when you're asked for multiplicities, you can look at the graph, or you can just look at the factors, and whatever exponent they have, that's their multiplicity. So if I put a 3 here, then that would make this one now have a multiplicity of 3. Whatever the exponent is, that's the multiplicity. Okay, when it's in factored form. That is really everything that you need to know for part 2. Okay, so if you're retaking Unit 8, Part 2, that's it. Okay, can you factor and solve? Can you write an equation from the zeros? And can you figure out the multiplicity? All right, if you can do those things, you are golden on this assessment. Okay.
When we use SOAP, do we only
Yeah.
use that on cubes?
Yes.
Okay.
Yeah, if that's only on cubes. If it's a difference of squares, that's one I didn't do. So let me do one of those really quickly. Okay, a difference of squares would be something like this. Okay, where both of those are perfect squares. And so the square root of this would be x. The square root of this would be 5. So it's 1 plus and 1 minus. Okay, so that's difference of squares. Okay, sum and difference of cubes is where you have to use SOAP. Anything else before I go to part 3? No, everybody's good? Okay. Part 3 is going to be regression with the calculator. So I'm actually going to switch over to my computer so that I can show you the calculator up on the screen. So give me a second to switch that over, and then we'll do part 3. All right, so this is the remediation assignment that I put in Classroom. That's what I'm going to use as an example. Okay, so we're just going to kind of go through these. So you're going to want to have your calculator. If you don't have your calculator, you're not going to be able to do this. All right, so first thing we need to do, okay, is we're going to go to menu and go to stat so that we can type all of these things in. So all of the times go in list 1 and all of the heights go in list 2. So go ahead and type that stuff in. Okay, so once you have them typed in, all right, the first part says decide whether the best fit model is quadratic, cubic, or quartic. Okay, so remember we're going to go to calc, so that's F2. Regression, REG, so that's F3. And we're going to try each of these different types of regressions, and we are looking for which R squared number is closest to 1. So a quadratic, that is x squared. All right, and it gives me the model, and R squared is 0.9986. Okay, so if I were you, I would just write it down, 0.9986. That's quadratic. All right, then I'm going to press exit. X cubed, that's going to give me the cubic regression, and there R squared is also 0.9986. So those two are equal. Press exit and look at the quartic, that's x to the 4th, F5. All right, and there R squared is 0.9986. So somebody did not proofread this question very well, because they are all equal. So we're just going to assume, so this will not happen on the test. Okay, one of them will be different. We're going to use the quadratic model just for the sake of picking one to do this problem. So we're going to use the x squared. Okay, so I'm going to go back and do the x squared again. Okay, and then when it says write the best fit model, they're asking you to write the equation. So remember, the calculator will always give you what the equation is. So it's ax squared plus bx plus c, and we're going to round to the nearest hundredth. Okay, hundredth means 2 decimal places. This is something that we messed up. Okay, so if I'm writing this equation, it is going to be y equals a, which is negative 4.99 rounded. Okay, so negative 4.99 x squared. All right, plus, if I round b, it is going to be 0.04 x, plus c is going to be 20.97. All right. I write that down for you guys. Okay, so y equals negative 4.99 x squared plus 0.04 x plus 20.97. All right, so that is our model. That's our equation that we're going to use. And it says, what is the height of the dive at t equals 0.3 seconds and t equals 1.3 seconds, round to the nearest tenth? Okay, t is time, and that's what we put in list 1. So those are x values. So what we need to do now is graph our model. So I'm going to go back to menu, and I'm going to go down to graph, and I'm going to type in that equation that we came up with. So I'm going to type in negative 4.99 x squared plus 0.04x plus 20.97. All right, that is my model. Go ahead and draw it. All right. I'm going to change my viewing window to the standard window. That's probably what yours looks like. If not, you can always do that. Viewing window, F3. F3 is standard, right? And then if you press enter twice, it will take you back to the graph. Okay, and we want to know what is the height of the dive at t equals 0.3 seconds. All right, and we said that was an x value. So GSolve, F5. And if I go over, so I press F6 to use that arrow, all right, we are doing a y calc. We know what x is, we're looking for y. So I press F1 and it asks me for the x value. I'm going to type in 0.3 and press enter. Okay, and so the height of the dive is, it round to the nearest tenth, so 20.5. All right, at 0.3 seconds, the height is 20.5. It also wants to know at 1.3, so I'm going to do it again. GSolve, go over, ycalc, and this time I'm going to enter 1.3. All right, so at 1.3, the height of the dive is 12.6, rounded to the nearest tenth. All right. At what time was the diver at a height of 18.5 meters? Okay, so that is the opposite. All right, height is a y value. So now I'm going to do GSolve. I'm going to go over and I'm going to do an x calc. All right, so an x calculation because I know the y value. So I'm going to put in 18.5. I want to know when the height is 18.5. Okay, the first number it gives me is negative 0.69 or negative 0.7 rounded. Okay, does it make sense to have a negative value for time? No. Okay, they didn't start the clock until he actually dove. So we're not going to use a negative value. I'm going to press the over button to get the positive value. So the positive value here is going to be 0.7. So at 0.7 seconds, that's when the dive was at a height of 18.5. All right. And then this last one, when does the diver hit the water and how do you know? So if I'm looking at this graph, where do you think the point is where he hits the water? Anybody have an idea? Right. The hit the water is going to be at 0. All right, wherever the x-intercept is, that would be hitting the water, having a height of 0. All right, so if I want where it hits the water, I want the 0, so I'm going to do GSolve root. I don't want the negative one because negative time doesn't make sense. All right, so he hits the water at 2.1 seconds if we round to the nearest tenth. Okay. The other thing, let me see what this second example is. All right, so this is the same type of thing, okay? And the answers to these are posted if you want to try this. It's the exact same type of question, exact same buttons that you're going to have to push on the calculator. The thing that trips you guys up on these problems is when they give you years and ask you to use a certain year as year 0. So like if I had a table, if I had a table that had 1950, 1955, 19 1960 and then 1980. Okay, and what the directions will say, like to use 1950 as year 0. So in your table on your calculator, you're not going to type in 1950, 1955, 1960. That's where we get messed up. What you're going to type in is 1950 is year 0. Okay, so 1950 is year 0. So that means 1955 would have to be year 5 because it is 5 years later. 1960 would be year 10 because it is 10 years after 1950. And 1980 would be year 30 because it is 30 years after 1950. So those are the actual numbers 0, 5, 10, 30 that you would type in your calculator. All right, when you're going to do those things. I think that's really the tricky part is when they give you years instead of just actual numbers to use. All right, so that's really all that I have as far as going through things. If you guys have questions, certain things you want to go over, let me know. I'll do whatever, however much review you need. Or if you're good, then you're good and we're done. I'm just going to sit here and same way we would in class. You guys can ask whatever questions you have. All right, Anthony, you're the only one left. So do you have any questions? Do you have anything else you want me to go over?